The mechanism of creep for a single crystal as depicted in the schematic is, okay. So we have single crystal, like this is a single crystal, and here, so single crystal means only one grain, right? So we can see that the point 1, it is marked at vacancy. So vacancy is going to the left side and to the right side, and here we have applied the stress. So here when we apply, so it will be tensile, so other zone will be in compression, because it will try to reduce its thickness, right? So this will in compression, here also compression, and here tensile. So in the tensile direction, there is a diffusion of mass flux. That means the atoms are moving towards the tensile, and the vacancies are moving towards the compression zone, right? So like you can see, understand, like suppose these are the atoms, and you can see these are the vacancies, right? The larger gaps. So if you are applying, so what is happening, it is getting thinner, and it is getting thinner such that all the atoms are getting accumulated in this zone, and these vacancies got accumulated in this zone, and because of this accumulation it is getting thinner, okay, like this. So this happens in which type of creep, okay. So you can think here, and you can remember the creep diagram, which is related to temperature, right? So like T by Tm, so something like this, okay. So like we have the Cobalt creep. Cobalt creep happens at slightly lower temperature. Then we have NH creep. Then at higher stress we have dislocation glide or dislocation creep, okay. Then we also have grain boundary sliding, but for that we need different grains, but here since it is single grain, so B will not be the choice. So like to see, cobalt creep happens at a lower temperature, right? So at a slightly lower temperature, the diffusion inside a grain is difficult. So mainly the diffusion in the grain boundary is preferred. So here there is no grain boundary, so there will be no choice for this cobalt creep. So what we will be left with? We will be left with Navarro herring creep. So this is happening at higher temperature, and diffusion is happening in the lattice. Dislocation creep is also not there, because here it is happening because of the stress value here. And in dislocation creep, the atomic movement like this doesn't happen. It only happens like this is the edge dislocation. So shifting of this to top portion, like dislocation climb, that is all called. So these type of things happen, okay.